In this module, we're going to talk about discrete math. Discrete math is the branch of mathematics that deals with discrete objects. Discrete object set is one whose values are not continuous but rather distinct and separate, like people, letters, shapes, whole numbers, each of which has a unique predecessor and a unique successor. Discrete math is used by computer programmers to create algorithms to solve real-life problems. We therefore study discrete math so that we can understand the fundamental algorithms used by computer programmers. In discrete math, there are three important tools that help us to describe and understand discrete math concepts: sets, relations, and functions. Let us begin by taking a closer look at sets. A set is an unordered collection of distinct objects. These objects are referred to as members or elements. The elements are separated by commas and they are enclosed with brackets. Sets form the basis of a lot of operations we carry out in discrete math. We can do a lot of different things with sets, such as combine them to form unions, separate them for intersection, or demonstrate the complement set, which is the set that contains all the elements not found in the universal set. A set union is any region that includes either of the sets. The union combines members of the different sets into one. This diagram shows an example of P union Q. To further demonstrate this union, let us add members to set P. We'll add 8, 1, 3, 5, and to set Q, D, T, J, L. Pause the video for a second and see if you can guess what is the result of this union. The result of P union Q shown here contains all the members of both sets. Notice that the order of the members does not matter. The next set operation we're going to look at is the set intersection. The intersection of set P intersection Q is the region that is common to both sets. Let us say that P is made up of 2, 1, 5, 3, and set Q is made up of 7, 3, 6, 1, 4. Pause the video and write down what you think will be the result of P intersection Q. The results of P intersection Q are the members that are common to both P and Q, which is 1s and 3s. Here is how we display the answer in text. Now, let us talk about complement set. This U shaded orange represents the universal set, which is usually drawn as a rectangle. The universal set contains all the elements under consideration. For example, a universal set of people will be the total number of people all over the world. A set of people from Africa will be a subset of the universal set. Let us move on to relations. A relation is a corresponding between two sets called the domain set and the range set, such that to each element of the domain there is an assigned one or more elements of the range set. Here in the domain set called hair color, we have the following members: black hair, blonde hair, and red hair. In the range set called people, we have the following members: Jose, Kafui, Leah, Sue, and Jada. Relationship mapping from domain set to range set is shown by the arrows as seen here. You will notice in this example, any given hair color in the domain set can be mapped to any number of people in the range set. A function, on the other hand, is a corresponding between two sets, the domain and the range, such that each element of the domain has one and only one mapping to the elements in the range. Here, the domain set contains a set of first names, and the range contains a set of last names. The function relation shown here shows how a one-to-one mapping from the domain set with the first names to the range set with the last names. Each first name is mapped to one and only one last name. This is a very important differentiation between functions and relations. In summary, we covered how discrete math uses discrete objects. We looked at the three tools that help us understand discrete math: sets, relations, and functions. With sets, we reviewed union, intersection, and complement. With relation and functions, we learned about the domain set and the range set, and so the crucial difference between them, which is that with relations, you can map one member of the domain set to one or more members of the range set, while in a function, a member of the domain set has only one mapping to a member of the range set.